Hello students, welcome to Chemistry Stars. In this video, we are going to discuss the calculation of spin-only magnetic moment of the given D block ion. Okay, so this is an important topic which can be asked in various entrance exams like NEET, JEE, and also this is an important topic which is there in your NCERT textbook, right? So let us see how to calculate the spin-only magnetic moment of the given ion. Okay. The formula which you have to keep in mind is spin only magnetic moment mu is equal to square root of n into n plus 2. The unit is Bohr magneton and it is represented as Bm. So this is the equation which you have to keep in mind. So learn here itself mu is equal to root of n into n plus 2 Bohr magneton. So this is a spin only magnetic moment. And here n represents, n means number of unpaired electrons. Number of unpaired electrons on that particular ion. This is given to you. Okay, number of unpaired electrons. So let us practice an example. See, first example, you have to calculate the spin-only magnetic moment of Cr3+. This is chromium ion, Cr3+. You have to calculate the spin-only magnetic moment. How you can do this? Okay, how you can approach this? You have to identify the number of unpaired electrons of Cr3+, right? So in order to do that, you have to know the atomic number of chromium, right? Atomic number of chromium is 24. It belongs to 3D series in the periodic table, right? Already I have uploaded a short trick to remember the 3D series, right? 3D series. This D block elements are very important, 3D elements. Okay. So you can see such questions from that particular series, D block. Okay, it is Scooty, Vikram, and I think you have, if you are studied your own code, it will be okay. The code which I have, I remember is like this: Scooty, Vikraman, Fikko, Niku, Zen. Okay, the code, the trick which I have, I remember is like this. And starting from 21, scandium is 21. Okay, atomic number 21. Then 22, it will goes like this: 23, 24. Singles 30. Okay, you have to remember this particular series. So from here, you will get the atomic number of chromium as 24, right? So the configuration will for free. Okay, it is not Cr3+, it is neutral chromium atom. Okay. For that, the substellized configuration is argon. Argon, it is noble gas configuration 18. Then you have to fill the 3D and 4s. It is 3D series, right? So 3D 4s. 3D and 4s subshells. So here 24 means, see, there is an exception in case of chromium and copper. Okay, chromium and copper. Okay, here 2 electrons will come. First subshell is getting filled. So here 2 electrons. For all other elements, it will be 2 here. Then comes, but in case of chromium, 3D5 is the stable configuration. So D5 is partially the stable configuration. So okay, completely that is filled, right? So it is stable and 4s1. Okay, this is the configuration of chromium. There is an exception in case of chromium and copper. It is the configuration is 3D5 4s1. So Cr3+ means here the chromium atom is losing 3 electrons, right? Cr3+ means it is losing 3 electrons. So the configuration will become argon 3D. From here 1 electron, and here from here 2 electron is lost, right? So 3. Right? So 3D3 is the configuration of Cr3+. Now I'm drawing that subshell, D subshell. Okay. I'm filling 3 electrons, 1, 2, 3. Okay. Here you can see number of unpaired electrons. 1, 2, 3, right? So n is equal to 3. Number of unpaired electrons in case of Cr3 plus is 3. So apply this into this particular formula. Mu is equal to root of n into n plus 2. That is 3 into 3 plus 2, which is equal to root of 3 into 5. This is equal to root of 15. See, root of 16 is 4, you know. So root of 15 will be 3 point something, right? So here the root of 15, the exact value is 3.87 Bohr magneton. Okay, 3.87 Bohr magneton. So that is the answer. So if number of, from this you can conclude that if number of unpaired electrons n is equal to 3, you are getting the magnetic moment mu as 3 point something, right? Exact value is 3.87. So 3.87. Now let us do another question. Okay. Here ion is not given to you. See, a coordination complex is given to you. Fe. Okay. Second question. Fe Cl6 4 minus. You have to calculate the spin only magnetic moment of this particular metal in the coordination complex. See, FeCl6 is a complex. So this question is somewhat related to, you can calculate the magnetic moment of complex, right? It is related to the coordination chemistry, that chapter also, because coordination complexes are formed by these d block elements, right? So FeCl6 4 minus is the complex, and you have to calculate the spin only magnetic moment of iron in that particular complex. So see Fe, the atomic number of iron is 26. You have to know. Configuration argon 3d 4s, right? So 4s orbital gets filled first, 3d 4s2, 3d6. Clear? Okay, it is 18. Argon is 18, 90, 20, then 26. Okay, so 3d6 4s2 is the configuration of neutral iron atom. Now, if you see here, the complex, you have to calculate the oxidation state of iron in this particular complex, right? So let us take the oxidation number of iron as X plus, sorry, X. Then 6 chlorine atoms are attached to Fe, right? So for 1 chlorine, the oxidation state is minus 1. So for 6 chlorine, it will come as minus 6, right? Minus 1 into 6 is equal to minus 6. Then here, the sphere contains 4 minus, it is an anion, right? So it is minus 4. X minus 6 is equal to minus 4. X is equal to minus 4 plus 6, which is equal to plus 2. So iron is in Fe2 plus, right? Fe plus 2 state. So Fe2 plus. So you have to write the configuration of Fe2 plus. Oxidation state of iron, you found it as 2 plus. So it is Fe2 plus. Now the configuration is argon 3d6, right? From s orbital to s subshell, that 2 electron is lost. So remaining 3d6 is the configuration. Now I'm drawing 3d subshell. Okay. 3d6 means 1, 2, 3, 4, 5, 6, right? 6 electrons. I'm filling 6 electrons. Okay, so here from here, clearly you can see number of unpaired electrons is equal to 4, right? This is paired. Okay, this is completely paired. Then number of unpaired electron 1, 2, 3, 4. N is equal to 4. So apply this in this equation. Mu is equal to root of n into n plus 2. It is root of 4 into 4 plus 2, which is equal to root of 4 into 6. Root 24. Root 25 means 5. So root 24 means 4 point something, right? And the exact value is root 24 means it is 4.9 Bohr magneton. 4.9 Bohr magneton. From here also you can conclude that if number of unpaired electrons is equal to 4, the magnetic moment you are getting is 4 point something. Okay, if it is 4, You are getting the number of unpaired electrons is equal to 4. You are getting magnetic moment as 4 point something. Here, the exact value is 4.9. Okay. So, this is, I hope this is clear to you. Now, can you tell me, along with me, you can also write, okay, you should write in your notebook. Don't just watch this video. You have to do the problems, okay, in your notebook. Tell me the magnetic moment of Cu2 plus, spin only, calculate the spin only magnetic moment of Cu plus. What will be value of Cu plus? Actually, Cu plus don't have spin magnetic moment, right? It will be 0. How? See, copper atomic number is 29. Okay. Copper atomic number is 29. So, argon 3D 4s. Okay, copper is an exception because here comes 10 electrons because it is stable configuration. So, 3D10 4s1. Okay, this is the configuration of 19, 19 plus 10, 29, right? 3D10, you have to write 3D10. For chromium and copper, that is an exception. This is a stable configuration, so you have to write 3D10 first, then 4s1. Now, Cu plus means, what is Cu plus means oxidation state, that is, it is losing one electron, right? Copper is losing one electron and become Cu means just 3D10. Here one electron is getting lost, so 3D10. Now I'm drawing 3D10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All electrons are paired, right? So n is equal to 0. There are no unpaired electron. N is equal to 0 means mu is equal to root of 0, right? 0 into 0 plus 2 means it is 0. 0 Bohr magneton. There is no spin only magnetic moment for Cu plus ion. What will be for Cu2 plus ion? For Cu2 plus ion, okay. Just calculate this and comment it below in the comment section. Okay, you have to answer the spin only magnetic moment for Cu2 plus. So from this, you can identify that. Okay, I can summarize number of unpaired electrons. Number of unpaired electrons. You only just have to identify the number of unpaired electrons in that particular ion. Okay, number of unpaired electrons. Then from here, magnetic moment. Okay, spin only magnetic moment. If number of unpaired electrons n is equal to 1. Okay, if it is 1, then it will be 1 point something. Okay, 1 point something. Let it be, exact value is 1.73. And if number of unpaired electrons is 2, it will be 2 point something. Okay, exact value is 2.84. Now, if number of unpaired electrons 3, it will be 3 point something, that is 3.87 exact value. 4 means 4.9 and 5 means 5.92. Okay. So just this is the trick in entrance exam also, when just identify the number of unpaired electrons. If you got n, then the magnetic moment, according to the option, you can choose the right option very quickly. Okay. For 1, it will be 1 point something. For 2, it will be 2 point something. That value you can choose that correct option. Okay. So let us practice some previous year questions from this topic. Okay. See, this is the question which is asked in JEE. Sorry, this is a question which is JEE. NEET 2020. Okay, this is a PYQ of NEET 2020. Calculate spin only magnetic moment of Cr2 plus ion. you have to calculate the spin only magnetic moment of Cr3 plus Cr2 plus ion. So Cr2 plus ion, right? So chromium, we know it is 24. So 3D, what it is the configuration? 3D5, 4s1, right? Okay. Now Cr2 plus means 3D4. Okay, 3D4. When I draw D subshell, 3D, here 3D, when I draw number of electrons 4, right? 1, 2, 3, 4. So number of unpaired electrons is equal to 4. So you got number of unpaired electron as 4. So 4 means it will be 4 point something, right? So this option will be only the right option is you in front of you is 4.9. Fine. Okay, 4 n is equal to 4 means the answer will be the spin only magnetic moment will be 4 point something. So only option with 4 point, which is 4.9 Bohr magneton. Very easy question. Right, this is the way you have to, how you have to approach. Okay, now hope this question is clear to you. If you have any doubt, you can ask in the comment section. Okay, this is the second question, and this is asked in JEE 2021. Okay, this is JEE means, sorry, JEE means 2021 PYQ. Calculate spin only magnetic moments of CrNH3 plus and CuF6 in Bohr magneton. The atomic numbers are given to you, right? Atomic number of chromium and copper. Okay, these two are given in the question itself, right? So when I take CrNH3 plus, this is the coordination compound, right? This is the coordination complex. So you have to find the oxidation state of chromium in this particular complex. So it is X, ammonia is neutral ligand. So X plus 0 is equal to plus 3. That is X is equal to plus 3. So chromium is in plus 3 oxidation state. So already we have said that when in the previous slide we got the for Cr3 plus number of unpaired electron is 3. So it will be 3 point something, right? For CrNH3 3 plus for this particular complex, it will be 3.87 Bohr magneton. Okay. So there are two options. This is 3.8. So you can cancel option B and option D. You can cancel this. To answer the A or C. Now let's calculate the oxidation state of CuF6 this particular complex. So here, first you have to calculate the oxidation state of copper. X fluorine means -6. So 6 fluorine, so X minus 6 is equal to -3. X is equal to -3 plus 6. This is equal to plus 3. So Cu here, copper is in plus 3 oxidation state, right? Copper is in plus 3 oxidation state. So plus 3 oxidation state means, see for copper, we know the configuration is 3D10 4s1, right? For Cu3 plus, it will be 3D. From here, 1 electron is lost, and here from here, 2 electrons are lost, right? So it will be 3D8. Okay, 3D8. Now I'm drawing this subshell. 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay, so number of unpaired electrons is equal to 2. Fine. Number of unpaired electrons is equal to 2. So when it is 2, it will be 2 point something. So option A is 2.84 is the right option, right? Here see it is 1.73, so it is wrong. 2.84 is the right option. So option A is the correct answer. Okay, 3.87 and 2.84. Okay, hope this question is clear to you. You have to work out and you have to find. Now, there is another question. Okay, this is asked in JEE main exam. Okay, this is somewhat a different question. This is asked in JEE main exam. There is no option. Okay, you have to answer it. You have to write the answer. The spin only magnetic moment value of most basic oxide of vanadium among V2O3, V2O4, and V2O5. Okay, you have to calculate. Okay, this is just the application level question, right? You have to calculate spin only magnetic moment of the. See, read the question carefully. As this is JEE main question, it is somewhat difficult, or it is application level question. Two concepts are applied here. Okay, read the question carefully. The thing which they have told you is most basic oxide. You have to calculate the spin only magnetic moment of most basic oxide of vanadium. Okay, here three oxides of vanadium are given. One is V2O3, another is V2O4, and another one is V2O5. Okay, from these you have to find out which is the most basic oxide. Listen carefully. You have to find out which is the most basic oxide. So in order to find out which is you have to calculate the oxidation state of vanadium in these three particular oxides. Okay, you have for V2O5 you have to calculate V2O3. First I'm taking V2O3. I have to calculate the oxidation state of V2O3. It will be 2x minus 6, right? Oxidation state of oxygen, it will be minus 2. So 3 into minus 2 minus 6 with equal to 0, right? V2O3 is a compound oxide, right? So 2x minus 6 is equal to neutral compound. 2x minus 6 is equal to 0. 2x is equal to plus 6. X is equal to 6 by 2, which is equal to plus 3. Okay, I have got here in V2O3, oxidation state of vanadium is plus 3. Now I'm taking the second oxide, that is V2O4. 2x, calculate the oxidation state. 2x minus 8 is equal to 0. 2x is equal to plus 8. X is equal to 8 by 2, which is equal to plus 4. So the oxidation state of vanadium in V2O4 is plus 4. Now I'm taking V2O5. Okay, now I'm taking V2O5. Oxidation state of vanadium here is 2x minus 10. Okay, 5 into minus 2, that is 10, is equal to 0. 2x is equal to 10. X is equal to 10 by 2, that is plus 5. So here the oxidation state of vanadium is plus 5. Plus 3, plus 4, plus 5. See, remember this, as oxidation state increases, acidity of oxide increases. Okay. As oxidation state increases, acidity of oxide increases. So the most basic oxide means it will be, okay, having less acidic character, right? Most basic means having less acidic character. So oxidation state is very lowest in V2O3, right? It is only, okay, it is only plus 3, right? It is only plus 3. Okay. Plus 3 is the oxidation state in V2O3. This is the lowest oxidation state. Lowest oxidation state. More basic character. Okay, basic character or basicity. More. So I can, because here it is plus 3, here it is plus 4, here it is plus 5. So most basic oxide is the oxide having lowest oxidation state, that is plus 3. So you have to calculate the spin only magnetic moment value of V2O3, that is asked in the question. Okay, this is what application level. You have to apply this particular concept into this question. Okay, this is JEE main question. That is why they are asking like this. So V2O5 means plus 3 oxidation state. Okay, that plus 3 oxide. You have to calculate the most. This is the most basic oxide. This is the most basic oxide among the given 3 oxides of vanadium. So you have to calculate the spin only magnetic moment of V2O3. Okay, V2O3. We got the plus, it is in plus 3 oxidation state, right? 2x minus 6 is equal to 2x minus 6 is equal to 0. So x is equal to plus 3. That is, here it is in plus B, vanadium is in plus 3 oxidation state. See, Scooty, Vikram, and Scooty V. Okay, V. That is 23. Vanadium atomic number is 23. So argon and 3D forest 3D2 forest sorry forest 2 3D3. This is the configuration of vanadium atom. So for vanadium 3 plus V3 plus, it will be 3D2, right? For vanadium it will be 3D2. Okay. Okay. So 3D2 means I'm writing number of unpaired electron will be 2. Okay, you can without drawing you can understand. Okay, now let I draw one. 3D2 means there are 2 unpaired electrons. So magnetic moment, spin only magnetic moment, it will be equal to 2 point something, right? 2 point something. So you have to answer it in nearest integer. Integer means a value without point. Okay, it is not a fraction. So see, you will get the it is root of 2 into 2 plus 2, right? Which is equal to 2 into 4. That is root of 8. Root 9 means 3. So root 8 means it will be 2 point something. Exact value is 2.8, 2.84. Approximately, you can take it as 3. Right? You can take it as 3. See, number of electrons n is equal to 2 means 2 point something. So you can't write it as 2. Okay, the correct value is 2 point something, right? It will be a high value like 2 point. It will be about 2.5. Okay, for a number of if one number of unpaired electrons is 1, it is 1.73, right? If it is 2, it is 2.84. It is if it is 3, it is 3.87. So for the okay, 2.84 means it is approximately it will be always equal to 3, and you cannot take it as 2. Okay, please don't write this here. If they are saying to round off the nearest integer, you have to take the nearest integer, that is 3. Okay, it will be not equal to if number of electrons n is equal to 2. The magnetic moment is 2 point something, means the integer nearest integer is the next number. Okay, 2 point means it is the next number, that is 3. So here Bohr magnet 3, Bohr magneton is the correct answer. Okay, so hope this question is clear to you. You have to apply some concepts while solving this question, as this is JEE main 2022 question. It is a somewhat application level question, right? So this is how you have to approach to such problems. Hope this question is clear to you. If you have any doubts related to any of this part, you can ask me in the comment section. And that's all for today's video. That's all for this today's topic. And for the notes and all, you can follow you can subscribe this channel. Okay, and also you can follow the Telegram channel. You can join on the Telegram group. So the link is given in the description box. Okay, so uh, uh till then, bye. Okay, we'll see in the next video. So thank you for watching this video.